Before we can move on to implementing some effects for our enemies, I have a couple of things to fix. So for now, our enemy chart is not a prefab. So let's delete the old charts that we have copied. Let's leave one around. And we are going to drag it into our _prefabs folder to make it into a prefab. Now, one thing that we will need to fix about it is if we go and extend it and go to our avatar, we can see that our shadow that was casted is still the shadow of our player. So what we are going to do is slide down, choose the shadow caster 2D, and we are going to edit this shadow to fit our enemy, remembering that it has some animation, so let's make it a little bit smaller. Okay. And of course, I think we could affect it by the animator, so maybe change the shape of it through the animator, or I'm not sure about it, but let's make an outline out of this to fit our enemy, at least a bit. Okay, something like this should be good. Okay, and now what we can do is choose our enemy chart, overrides, and apply all. Great. Now, what I would like to do as well is, if we press play, we can see that our impact particles, our impact prefabs, are affected by light. It is much more lit here than when we shoot near the torch. And the same things happens for our enemy impact prefab. And it is white, so it is barely visible when we hit our enemy, since our enemy is also white and red. So what I would like to do is, first of all, go back to our prefabs folder and select our impact obstacle prefab. And I would like to go to its sprite renderer and change in the additional settings the sorting layer from foreground to the bullet. Since bullets are not affected by light, we also want the impact obstacle prefabs and enemy prefab to not be affected by light. Now, good thing about making the enemy prefab impact prefab to be a variant is that now it has also the setting that we have changed in our impact obstacle prefab, so we have this sorting layer set here as well. Now, for our impact enemy prefab, we would like to change the color from white, since it doesn't really work, to something like maybe yellow. This is the same color as the bullet, or very similar, so now it only has been changed in the variant, not in the base prefab. So this is the power of variants and prefab variants. We can test it by duplicating our enemy, Ctrl D, choosing the move tool in our scene view and move the enemies around to test how our impact prefabs are working. So let's press play. Now our impact prefab that is for the obstacle works great, and for our enemies you can see that the yellow color makes the impact effect much more visible. So this is great. Now, in the next video, we are going to start implementing we are going to talk about the enemy effects and how we are going to deal with turning our enemy white. Since right now, if we select our enemy chart, extend it, choose the avatar, and what we are going to do is choose the color, so you can see that we cannot really make our enemy white. We can make it black, but this is even less visible. So what we are going to do is we are going to make our enemy flash white, and for this we are going to need to implement a custom shader. So this is what we are going to talk about in the next video. See you there. In the previous video, we have performed some minor fixes to our project. So we have fixed the shadow of our enemy, and we have fixed the impact prefabs that we spawn when we hit the enemy and the obstacle. Now, what I would like to do is I would like to talk about the effects that we can implement to our enemy. We have implemented the death coroutine, so our death coroutine will wait for the sound to be played before our enemy is being destroyed, but we are just disabling the avatar, the sprite render. Now we are going to change it. We are going to implement a shader, a dissolve shader, so our enemy will kind of dissolve into a thin air before it is destroyed. Now before we can tackle it, let's talk about what shaders are. Okay, we are in Unity manual, and we can see that for the graphics section we can see the meshes, materials, shaders, and textures. So meshes are the main graphic primitives of Unity, So they are the objects, the shape of the objects. The materials define how surface will be rendered, and the shaders are small scripts that contain the mathematical calculations and algorithms to calculate the color of each pixel that is rendered based on the light input and based on the material configuration. And the texture are, of course, the bitmaps images that we apply to our objects. Now, you can already see that the shaders are a way to tweak how we are rendering the game object. But in Unity, we can only apply those shaders by creating a material and then applying the material to our game object. Okay, let's go back to Unity. So we will want to create a custom shader and a custom material for our enemy. Lucky for us, for the universal rendering pipeline and the new HD rendering pipeline, Unity has implemented something called shader graph. Okay, so we can see the about shader graph in Unity manual about shader graph. Shader graph enables you to build shaders visually. Instead of writing code, you can create and connect nodes in a graph framework, and graph gives us the shader that we would otherwise create through code. And you can see that it is only available for universal rendering pipeline and a high definition rendering pipeline. So while the shader graph is not as powerful as what we can do with the scripting language for the shaders, we are still good to go because they are much easier to use. So that's why we are going to use the shader graph. To make sure that we have our shader graph, we can go to our window, open the package manager, and what we can do is wait for it to fetch packages. And when it is done, we can type simply shader, and we should see the shader graph, and it is verified package, and it is installed and up to date in my project. That is great. So in the next video, we are going to start creating our shader, our custom shader for the enemy. So see you there. In the previous video, we have talked briefly about what are shaders. Let's now create our custom shader. So first of all, let's go to our assets folder in the project section, and we are going to right click, create a new folder. Because shaders are applied through materials, we are going to call it _materials. Okay, let's open this folder. A bit of an update. For Unity 2020.2, the shader graph has been updated a bit. So we are going to explore the newer version of the shader graph that works with Unity 2020.2. If you are following this course in Unity 2020.1, the old version of this video will be available in the section 1 before the last section. There will be the older videos for Unity 2020.1. So what we want to do is we want to go to _materials. We are going to right click here, create, and we are going to select shader. And here we should have different types of shaders. Now, since our shader is using universal rendering pipeline, we need to select this one. And we have lit shader graph, sprite lit shader graph, sprite unlit, and unlit. Now, since we are using sprites because this is a 2D game, we want to, of course, create a sprite shader. And since we have lights in our game, we are going to select sprite lit shader graph. So let's select this one and let's create it in our materials folder. Let's call it enemy default shader. Okay, and we can double tap on it to open it up, and this will open our shader graph. Now, before we start creating this shader, in the resource section for this video, we will have a PNG file to download that contains one frame of our enemy. I have downloaded it onto my desktop. I'm going to drag it into our sprites folder, and we are going to use it when we are creating our shader. So let's extend our Unity window, and now what we can do is make sure that we have in our sprites folder our short idle anim f0. Let's make sure that we set the properties here, so make it a sprite. Set the pixel per unit value to 16, I think. It doesn't really matter for the shader. We're going to make sure that this is set the filter mode to point filter, and the compression, let's set it to non-compression to make it look like a pixel sprite. Okay, that is it for the preparation of the sprite. Now, what we are going to do is let's go back to our underscore materials folder and let's double tap on the enemy default shader. Now, when we have our enemy default shader graph window opened, what we can do to maximize it is simply right click on the tab of our enemy default shader in the scene view and select maximize it. Or we can go back by doing exactly the same, clicking on the tab, right click and uncheck maximize it. Or we can detach it and maximize it as a separate window. This can be useful if you have two monitors. I'm going to minimize it, I'm going to dock it back, or at least try to dock it back, and I'm going to right click and maximize it. Great. Let's now go to the documentation and let me explain how the shader graph works. Great. I advise you to always check the documentation for new elements of Unity that you are not familiar with. So here we are in the shader graph version 10.2.2, creating a new shader graph section. And we can see that this describes how we create a shader that can use the shader graph. And this is the shader graph window, what we have seen previously. And it contains a couple of elements. First is the preview window, which is in the bottom right corner, and this is the preview of whatever we are working on, so we can import a model. In our case, we are going to import the PNG file that we have downloaded from the resource section, so that we can see on the sprite of our chart how our shader will work. Next, in the top left section of our window, we have what is called a blackboard, which contains all the parameters that we have created for our shader. So those can be colors or boolean flags or whatever you want to expose for the user to be able to use to modify how your shader acts. And we have an additional window, which is the graph inspector, and you might not have it already opened in your window in Unity, because it is opened through those buttons in the top right corner of Unity. And those parameters in the graph inspector represents the parameters for our blackboard, for the parameters of it, as well as it has a section for the graph settings, so the settings of the whole graph. And one last thing that we are going to create is a simple node. So nodes are the elements of our graph, and this is an example of add node, and we are going to explore how we are going to create those and how we are going to use those when we are creating our graph. Okay, that's it for the theory. Let's go back to our shader graph in Unity. Great, we are back in Unity. Now the graph inspector is in the bottom left corner in my case, because I have dragged it from here. You can open it if you do not have it open using this top right corner of Unity, selecting the graph inspector toggle. And you can drag it underneath the blackboard just by dragging it, since we are going to add a couple of parameters here. And in previous version of shader graph you could have seen all the parameters here. Right now you will have to create a parameter here and then view the settings for it in the node section here. Okay, now back to our pre-created nodes. It is pretty vital that you know what is going on here. Now we have two objects or two nodes, vertex and fragment. Every shader is made out of the vertex part, which is responsible for tweaking how our object looks, so it modifies the position of the vertices of our object. Now for 3D models, it can be that we bend or tweak how the model looks like. For our 2D graph, we are barely going to use it. Now fragment is a node responsible for adding the color. Now this is important if you want to learn more about the shader graph, but in this course we are going to only study the basics. Now for our needs, we do not have a model, so in the main preview we now have a sphere or a circle, but what we have is a sprite. So what we can do is go to the main preview, right click here and select quad instead of our circle. Now quad is a flat object, so what we can do is simply put a texture on it, and we are going to see how our sprite will look when we create our shader. Okay, so we have our preview, we know what are those nodes that were pre-created. Now let's go back to our blackboard, and we are going to select the plus icon, and here are all the parameters that we can place in our shader. Now vector 2, vector 3 and vector 4 are simply an arrays of vector values. So we have vector 2 is an array of 2 float values, vector 3 of 3 float values, vector 4 of 4 float values, color is a color, boolean is a boolean value, and we have texture 2D, which we are going to use for our sprite to import the sprite so that we can show it in our preview and so that we can tweak it later. So let's select the texture 2D node. You can read more about those nodes in the documentation of the Unity. Now, if we select this texture 2D, in the graph inspector we can see the parameters of it. Let's change the name to call it main texture. And now we have the reference. Reference is the reference that we can access through our scripts so that we can modify the main texture through our scripts. And we will need to change the name, so click on it to underscore and let's call it main text. And this is pretty important. Okay. Now in Unity, we place our shaders on materials and the render object of Unity, be it 3D renderer or 2D renderer, takes the material and pushes it onto an object. And we can see that the material has a getTexture method, and getTexture has the main text property, which is referencing the main diffuse texture. And this is pretty important because Unity renderer accesses the main text as the texture to display. So if we call our shader texture as it, we will be sure to display this concrete texture as the texture for our object in Unity. Great, let's go back to Unity. Okay, we are back in Unity. We can select the default texture and we should have our sprite that we have imported from the resource section. Let me find it. The name was chart. And we should have chart idle anim f0. And if we select it, you can see the miniature version of this sprite shown here as the default texture. This is only for us to check how it looks like. And basically, if the sprite render receives the texture from the animator, it will be saved as the main text. So our material will be able to get it from our renderer and process it further and push it back to our sprite renderer. And this is why this is important, so we have this name as the reference. Now, we can leave the mode white, precision inherit. Expose means that we see this parameter in the inspector of Unity, so we can set it by hand. And again, you can read more about those in the documentation for Unity. We are not going to change those settings. Right now, what we want to do is select our main texture from our blackboard and drag it into our shader graph. Now, since this is a texture 2D, as you recall, and here is a type, we need to process it so that we can pass it as a color, as a mask, as a normal, or as an alpha value to our fragment. Since I have told you previously, this is responsible for processing the colors of our object and displaying them on the object that has this material. And here is where we want to work with our nodes. Now, to create a node, we can either right click and create node, and we can type the node that we want to create, or we can press spacebar and we have the same window that we can type here what we want to search for. Now, since each type of node represents a different setup, I'm going to post a reference to the Unity documentation for those. What we want to do is to create sample texture 2D node. And this takes a texture and converts it into color, so RGBA. This is 4-channel color, as well as red, green, blue, and alpha color. Now, since we have split our texture into different colors and different channels, we can drag this RGBA to our color, and we should see our sprite. But as you can see, this is not transparent. We can see a black background behind our chart. This is because we have output RGBA, so 4-channel value, and we have dragged it into a color, but our fragment shader has also alpha, which is our alpha channel. So it only uses RGB value, and A is discarded. Now this is important because if you have no alpha channel, you will have a background with your sprite, and we do not want it. We want it to be transparent so our sprite can stand on its own. So what we want to do is drag from our sample texture to the A value, which is alpha, which is transparency, And here in the preview you can already see that there is transparency. If we remove it, we can select it and delete. You can see that it has added the black outline. We are going to add alpha back. Now this is great, but we do not want to output the same sprite here. We want to make it into a solid color. So what we are going to do is we are going to add here in the blackboard another property using this plus icon, select the color, and let's call it solid color. Enter. Select this and you can see in the graph inspector the property. Let's change the reference to underscore solid color in case we want to access it through our scripts. And now we want to set the default color. Let's select it and let's select the white color. And now we should be good to go. Now let's select it and make sure that the alpha is set to 100 instead of 0 because we want to have the color to be solid and not transparent. Great. What we can do is we can drag this color into our graph and we would like to multiply the output of the sample texture by this solid color so that we can make this sprite to be a single solid color. And to do this we are going to create a new node. If you can recall, press spacebar or right click, create node, and let's call a multiply node. And just to understand, those nodes represent the mathematical operations that we perform between two values. What I would like to multiply is the alpha value of our sprite. So let's drag it to our B input for our node. And let's select our solid color as the A input. Now we are outputting a color array, so RGB are outputted here. And we have multiplied simply the alpha channel, so what is not transparent, by a solid color. Now, instead of passing this RGBA value from our sample texture to D, we're going to delete this node and we are going to select our output from the multiply and drag it as our base color to our shader. And now you can see that our sprite has become white. Great, that's exactly what we wanted. Let's go to the top left corner of Unity and let's select Save Shader so that it has been saved. Let's right click on our shader and let's select Maximize to be unchecked. And let's continue with the old version of the video. So now we have our shader ready. To apply it, we will need to go to our underscore materials in the project section, right click on our shader, create, and we are going to choose the material. And this automatically creates our enemy material. So let's call it like this, enemy material. Okay. To apply this material, let's select our enemy chart. We can close this shader, right click here and close this tab to see our scene window. We can select our chart, we can select our avatar, and simply let's drag our enemy material here where our avatar is. And you can see now that if we press in the previous video, we have started implementing our shader in our underscore materials folder, and our shader currently makes our enemy white. That's not what we want. We want it to briefly be white only when we hit it with our bullet or with our weapon, however we want to create the game. For now, we are going to reopen this shader by double tapping on it, and it should open you the window for the shader. I'm going to right click here and maximize it just so that you can see. By the way, to move around in the shader, you hold scroll. To move in this window, to zoom in and zoom out, you scroll in and scroll out. This is the updated version for Unity 2020.2. So this is our current graph that constantly outputs the solid color for our sprite. Now, to tweak how the sprite looks, we would like to have some kind of an if statement to say, if I have been hit, so if enemy has been hit, change the sprite to be white, so to be solid color, and then tweak it back to be colorful again. So to introduce this kind of if functionality, we are going to press spacebar or right click and create, and we are going to type branch. So branch, like in a tree, we have a branch, so this will connect two inputs, so two branches, and we output a result. And as you might imagine, so if we delete this output from the multiply connection to the fragment to the base color and drag our AGBA from the sample texture to D, we have our colorful image. Now instead, what we can do is we can assign the multiply output to our true value of our branch, the sample texture RGBA output to our false value, and as you can see, the branch has the predicate, which is simply a bool value. If we select true, it will output the output from the multiply node. If we select false, it will output the sample texture output. And this means that we have the output that transfers each of those depending on this predicate. So we can drag this output as the color of our fragment, and if we select the branch and we select true, it will become white, or solid color rather, and we select false, it will become the colorful sprite again. Now of course nobody will be here clicking this whenever player hits our enemy. So we will need to expose a parameter in the blackboard so that the user can set through the code what should be the output of our shader. So now let's create another variable in our blackboard by clicking plus icon, and let's select the boolean value and let's call it make solid color. Okay, if we select it, we can see in the node settings in the graph inspector the parameters of it. Let's change the reference of it from this long string value to underscore make solid color. So we are going to set the default to be false, so by default we will see the colorful image when we attach this shader or the material made out of this shader to our sprite. So we have our make solid color node. Let's drag it and let's make some space by dragging those nodes a bit, and let's drag our make solid color as the predicate input for our branch. So now if we select our make solid color node settings in the graph inspector and we select the default value, you can see that the image is changing. Great, so that's it for this fix. Let's save the asset using in the top left corner using the save asset button, and let's go back to the old video. And what we can do is go to the scene view, and if we go to our chart that has the shader and to its avatar and find the material that has the shader, we can now click the solid color, and you can see that it has changed to be solid color, and uncheck it to make it colorful again. And to get the reference to the properties that our shader has, we can simply go to our underscore materials, open up the shader, and at the bottom of it you can see all the properties that it has. And I believe that if we go back to our shader and uncheck the expose value and save it, now our shader will not have this field. So you may want to make sure that you have the exposed checkbox checked and save the shader, and now our shader in the assets file will have this field and this property exposed, so we can tweak it through the script. And now this looks very good for our player, for example, on a hit. So maybe we should go to the underscore materials, choose the enemy default shader, Ctrl D to make a copy of it. Let's F2 to rename it, or you can rename it through the, I don't think you can rename it through the inspector, so F2 or double tap on it, and let's call it maybe sprite slash lit. Okay, just to indicate that this is a lit shader, and what we can do is right click here, create a material out of it, and let's call it maybe the same name, sprite slash lit material. Okay, so now what we can do is go to our player, extend it, go to the avatar, and drag our sprite slash lit material. And now what we will be able to do is simply change the color of our player. When it is hit, it will become white for a bit, just to indicate that our player in turn was hit. Great. So let's quickly create a custom class in our script, in our feedback, to make it work, to make our shader work. So to make this work, let's create a new C# script here. Let's call it flash feedback or flash sprite feedback. Okay, let's open this script up in Visual Studio. Great. Let's delete the start and update methods. We are going to create them as we need them. let's extend not monoBehavior but feedback class, our abstract class. We need to click on a flash sprite feedback and Alt-Enter because it will want us to implement the abstract methods. Now, there can be two situations. Either we have our material with the property that we have created, so make solid color, or we don't. So first of all, we will need to have an access to the material itself. Let's create attribute serialized field. Let's create private sprite renderer. That will be the sprite renderer that we want to tweak. So let's call it sprite renderer. Equals null. Next, we want to have a time in which we want to keep the shader to flash, and then we want to turn it back to be colorful again. So let's create another serialized field, and let's call it private float flash time. Let's set it by default to be 0.1f. Next, we need to deal with the situation when our material doesn't have our property. So let's create serialized field, and we are going to get the reference to the material, private material, and we are going to call it flash material. Equals null. And to save the old shader in case we have the different shader applied to our material, since do remember that material takes in shader, we can have a material with different shader and we can assign to it a shader. So let's create a private shader, and this will be original material shader. And we are going to make sure that we save the original material shader before we swap it with the flash material shader, so that we can tweak it, make it flash, and we can turn it back to the original shader in case this shader does something. So we are going to create start method, start, and here we are going to assign original material shader equals our sprite renderer, and we can access our material and for the sprite shader, and we are going to access the shader itself. Okay, so we have saved the original shader just in case. Now, to complete previous feedback, we will need to simply again call stop all coroutines, because we are going to use coroutine to change the shader and to wait a bit. And we are going to call our sprite renderer dot material dot shader, and we are going to make sure that it is back to being the original shader. Great. And last thing that we will need to do is we are going to create a coroutine. So what we can create is IEnumerator. Next, we are going to call it wait before changing back. Okay. And we are going to call here yield return new wait for seconds. And we are going to wait for seconds, which is the flash time that we have given it. So this will make our coroutine, it will make it wait. Okay, I have misspelled it, so I'm going to rename it then coroutine, wait before. Okay. And what we are going to do after we return yield, we are going to check if our sprite renderer dot material dot has property, which allows us to check if the shader has a given property. And we will need to make sure that we type exactly the name that we have for our make solid color property. So I think we had underscore make with capital M, solid with capital S, and color. Again, you can save it, you can go back to Unity and enter the underscore materials, check the sprite flash lit, for example, and you can read the property. I don't think you can select it, so you can just retype it on open the shader and simply copy this, Ctrl C, and then go to your script. Okay, I'm going to make sure that it is correct by pasting the name. And let's open the parentheses for this if statement. And what we are going to do is we are going to call sprite renderer dot material dot set int. Since if you want to set a property, we need to call a set, but if you call set, we do not have exactly set boolean value. So we need to use set int, since boolean is just 0 or 1 value, and we can cast it as an int value. and we are going to make sure that we paste the same name for the property, and we are going to set it to 0. So we want it to be false. After we wait a bit, we want to reset the image to be colorful, so we want to make solid color to be false. So 0. Else, so in case we do not have this, we can again copy the same code from the original materials, from the complete previous feedback. Although I don't believe we will ever reach this else statement, but just in case we can leave it like this. So now let's copy this if statement and let's slide up to the create feedback, and we are going to paste this inside our, instead of the throwing an exception, we are going to paste the same code. If our sprite renderer has the property, we are going to set int and set it to be 1 instead of 0. And now if the sprite renderer doesn't have, the material doesn't have this property, we are going to set it to be our flash material dot shader. So we are basically swapping the shader to be the flash material shader, and this will allow us to have this property. Or actually, let's cut it out, let's paste it below, and let's delete this else statement, and we are going to check if this sprite render material has property is false. Then we are going to reset the shader, and we are going to make sure that our sprite render material set int is called on a shader that has this property. Okay, now that's better. And last thing that we will need to do is call start coroutine, and let's start our wait before changing back coroutine that we have created in a bit. Let's save it. Let's go back to Unity. Great. I'm going to close those shaders or shader graphs, and I'm going to go back to the scene view. Now what we want to do, let's open up the enemy chart, and since we do not have any feedback or game objects here, let's right click, let's create empty, and we are going to rename it to feedback hit. Okay, make sure that the transform is 0, 0, 0. And what we are going to do is we are going to add components, and we can add our flash sprite feedback, and we can assign our avatar as the sprite renderer. We can set the flash time to be something like maybe 0.05, and we can assign our from our underscore materials folder our sprite flash lit material in case our sprite renderer doesn't have this material with this shader. Okay. Last thing that we will need to add here is our feedback layer. To our feedback layer, let's drag our flash sprite feedback. So let's click on our enemy chart, and we are going to go to our onGetHit. Let's add here a position. Let's drag our feedback hit. Let's select the function feedback player, and let's select the play feedback. Great. Now what we can do is select the enemy chart that we have edited, go to the inspector, overrides, and apply to all, so all enemies have it. Let's try playing, and let's try shooting it. It works, yep, but it is very short, so let's modify it. Let's select the enemy chart, or we can stop the game and simply select one of those, select the enemy feedback, and let's set it to be 0.1. So let's see if it works better. Let's play it. Okay, it is more visible. So we can play around with those values for the enemy chart. I'm going to save the override that I have applied, so this change of time. And now what we want to do is we are going to have a different effect when we shoot the enemy. It disappears, but I would like to extend our enemy shader. Let me show you in our finished project. I'm going to shoot this enemy, and you can see that it disappears in kind of red flames, something like this. So I want to achieve this effect, and we are going to implement this to our shader in our project in the next video. See you there. In the previous video, we have implemented a feedback to our enemy, so on shoot, we are going to flash our enemy white. We can do the same for our player, so just to finish the previous video, let's go to our player, right click, create an empty game object, rename it to feedback hit in the hierarchy. Now, what we can do is add to it our feedback player and add to it flash sprite feedback. we can use those three dots to move the component up, to have it above and the feedback player below. We can drag our avatar to our sprite renderer. We can make sure that we drag our sprite flash lit material to our flash material. Let's leave the time flash as 0.1, and what we can do is drag the flash sprite feedback to the feedback player, to its list, and now choose the player, and on hit we are going to add this feedback hit. Choose the function feedback player and play feedback. We can press play, and now if enemy walks towards us, we can see that our player also flashes white. Now nothing happens on that, we are going to get to it, but for now let's finish off our enemy and let's implement our custom dissolve shader to make our enemy appear, the depth of our enemy appear much more spectacular than just disabling the sprite. So let's save the project with our changes to the player, and now what we want to do is go back to our enemy default shader. Make sure that you do not modify those properties since we have copied this shader. I am not aware if we can create some kind of duplicate in a way that those are two connected like shader variant. I suppose not, so make sure you do not change this make solid shader because our feedback relies on it. Let's open up our enemy default shader. I'm going to right click here to maximize it. Updated version of the dissolve shader. Now, before we can tweak this shader graph to output a dissolve version of our sprite so that we can indicate the depth of our enemy through the changes inside the shader, inside its how it looks like, let's start by adding a couple of parameters here. In the blackboard, let's use the plus icon and let's select the float. Let's call it dissolve. So this will be the value that represents how much the sprite is dissolved, and we are going to tweak it through the script. So our sprite goes from being solid, colorful sprite, we're going to dissolve it just so that it disappears to indicate that the enemy is dead. Now let's change the reference in the graph inspector in the node settings to be _dissolve. Now this is pretty important because we are going to access this through our script. Now, what we can do to make sure that we do not tweak it too much is to select the mode, and the mode allows us to set how the value is displayed in the editor. If we can select enum, integer, and slider. Now slider will create a simple slider that has a minimum and a maximum value, just like we add a range attribute to our parameters in the Unity scripts. So this will add a slider from 0 to 1. Let's set the default value to 0.5. And this will be it for the changes for the dissolve parameter. Next, we need to add another float. So let's add plus icon float, and let's call it noise scale. We are going to use Perlin noise for our dissolve shader. So we will need to have this noise scale so that we can control it through our scripts and through our editor. Let's select the graph inspector and let's change the reference to _noise scale. Okay. Let's set the default value to be 20. Great. Now, next parameter will be again a float. So let's add parameter to our blackboard float and let's call it dissolve outline. And we will add an outline indicating some kind of effect, be it blood or be it some kind of energy or fire. So we want to add some kind of outline to indicate that something is happening, that it is not only disappearing, the sprite is not, the enemy is not disappearing, but also that it has been hurt, or that maybe we have a laser gun and the laser has burned our enemy. So basically this is why we need this dissolve outline. Let's select the reference and let's set it to _dissolve outline. Okay. And again, we can set it to be a slider in the mode section, and let's set the default value to be 0.05, and we do not want to have too big outline, so let's set the max value to be 0.2. Great. Last thing that we will need to do is to have a dissolve color. So let's select the plus icon, let's select the color, and we have it here, and let's call it maybe dissolve color. Okay. I have misspelled the first dissolve. I'm going to fix it. Okay. And so this dissolve color will be basically the color of the outline of our dissolve. Let's select the reference and let's set the name of the reference to be underscore dissolve color. Okay. Let's set the default value to be red and make sure that you change the alpha from 0 to be 100 so that the outline is fully visible. Of course, you can make it with some transparency. Great. And this will be it for the parameters. Now, as it comes to our shader, we have this branch that allows us to change the shader look to be a solid color. And if this is false, we will pass the RGBA from the sample texture to D. So we are going to delete this line connecting the sample texture to the branch, and we are going to put here additional code or additional nodes that will allow us to create this dissolve effect. I'm going to drag vertex a bit farther. Okay, just to make some room for our new nodes. So as I have previously mentioned, we are going to select a area which should be set to be transparent, so to invoke this dissolve color effect by creating a noise from the Perlin noise node. So I'm going to simply create a node by pressing spacebar, and let's call noise, and we should have a simple noise. Great. Now, as you can see, simple noise takes the parameter UV and a scale. Now we have our noise scale as the parameter, so let's drag it here and let's pass it as the scale. And you should see that we have a bit bigger scale for our simple noise. And because we will be not using a sprite but rather a tile map, we will need to add here a position node. Since, as I have previously mentioned, the sprite is taken as a whole for our material. And since Unity have no idea that we are using only the single sprite and not the whole tile map, we are going to pass the position and set the space to be object space, so that we are going to modify using this sample noise only the sprite that we have as our input for this sprite render, not the whole tile map. Basically, we need to do it to receive a correct result. Let's pass the output of the position to our UV, and now it will affect only our sprite and not the whole tile map. If we were using only the single sprite, it would work without this position. Now next, of course, we need to affect our sprite using this simple noise. So we will create a node called step. So let's create a step node. Okay. And the step node can take a value and apply the amount of this value to the input. So basically, we can pass a simple noise as the input. Okay. And if we change the x value, you can see that we can take a step, and the step in this case is the threshold of the how much white should be in our color, so that we can accept it as above the threshold that we set in our step node. And this will be the dissolve parameter that we have created in our Blackboard. And let's pass it as the input here for the step node. Great. Now we would like to apply this step to our texture, to our RGB from our sample texture 2D. And for this we will multiply those results, so create a multiply node. And we are going to multiply our output from the sample texture 2D. So let's drag this RGBA value as the A input. And let's drag the step input as the second input for the multiply. Now, if we drag our multiply to our color, we can see that empty spaces, but they are still black, since our alpha value doesn't know that this is now empty, and it should be taken as, it should have alpha set, I think, to 1. So this is the transparent value. So we will need to also modify the alpha value of this. So let's create multiply. And we are going to multiply the result of this step and the alpha value. And now if we drag it instead of this basic alpha, if we drag it as the input for our sprite, you can see that now indeed those empty spaces are transparent. And if we select our dissolve parameter and set it to be something like 0.4, you can see that we are dissolving our sprite, and at some point it will be nothingness, indicating that the enemy has died. If we set it to 1, it is the same sprite that we have passed it as the texture, Now, of course, the issue is that we have passed this result from the multiply nodes to alpha and to the base color, but we are using this branch to control everything. So instead of passing this multiply result to the fragment, we are going to pass it to the branch. And of course, to pass the alpha, we need to also create a branch. So let's create a new node branch. And we are going to pass this alpha output from the multiply node to the false value, since the false value takes the multiply from the dissolve part of our shader. And let's pass the alpha value from our sample texture to D as the true value for our branch. So this will allow us to pass the correct alpha based on the same make solid color parameter. So let's drag again the make solid color as the predicate from our second branch, and let's pass the output as the base color. And if we select the make solid color in our blackboard and set the default value to true, we can see that now it is back to white, to the solid color that we have set. And if we uncheck it, it is back to being the dissolved result. Now, last thing that I wanted to add was the outline, just to indicate, to add this effect of the blood or to the fire, which is the cause of the dissolve. And to add it, we will need to add a couple of nodes. We will need to subtract the value of our dissolve parameter from our dissolve outline. So let's go back to the beginning of our graph, and we are going to create a new node. Let's call it subtract. And we want to subtract our parameters dissolve. So let's drag it here and let's pass it here. And we want to pass here the dissolve outline. Now, to get the values for it, we are going to create another step. And the step will take the output of the subtract node. And we are going to take the output from our noise. So this will give us a bit of a smaller result than this step gives. And if we subtract both of those, so let's add subtract node, we will subtract this bigger value of the step value from the smaller value, and this will give us this outline, so the difference between those two steps, and this is caused because of the subtract node here. So now we have our outline, and we would like to add to it the dissolve color. So to do this, we are going to add a multiply node, and we are going to multiply the result, so this outline, by our dissolve color, which is on our blackboard. I'm going to drag it here, and I'm going to pass it. And since the dissolve outline is by default set to red, we have this red outline. Now, the difficulty is that we now want to apply this outline to our result from the multiply node of our RGB and the step. So we will need to add this red outline to our result of the multiplication of the RGB texture 2D and the step from our dissolve shader part. So let's add node. Okay. And we can, instead of passing to our branch the multiplication result, I'm going to drag it a bit, we are going to pass the result of our addition. So let's delete this connection between branch and multiply. Let's add this multiply result to our add node, and let's add the multiply from the outline to our add node, and we have our result. So let's drag the result of our addition to our branch, and now as you can see, the red outline has been added, the transparency has been added through the second branch node, so it all works fine. And if we select our dissolve, we can change the value to be 0.4, 0.3, and the outline is getting bigger. And of course, you can change the outline width by selecting the dissolve outline, and it should give you the bigger outline the bigger you set it to be. Okay, great. So I'm going to select the dissolve, and I'm going to set it to be 0.5. And this is our dissolve shader that we have implemented for our sprite to indicate the death of our enemy. And of course, again, we can select the make solid color, select the default value to true, and we are back with our solid color, so we can still indicate that the enemy is hit, although we are going to disable this functionality through our script. So when the enemy dies, we are going to disable the collider so it doesn't collide with anything, and this will be just the graphical output of the enemy being killed. Great! So let's select the save asset in the top left corner of Unity, and let's select the enemy default shader and let's unmaximize it. And just to show you, we can select our shader, and in the shader and in the material, we have those properties exposed here, and those will allow us to tweak the settings for our shader through the code, through the C# scripts as we want them to be. So the dissolve shader, we will use this dissolve parameter to make our enemy look like it is dying, and we are going to tweak it so it runs constantly in a coroutine, for example, so that we can create this custom death animation using our shader. So see you in the next video. In the previous video, we have implemented the shader or dissolve shader for our enemy. So if we go to our enemy chart, we go to the avatar and slide it down, we should see that we have this dissolve value, and we can use it to dissolve our enemies. Now right now, this drives all enemies because this is the general shared shader. Now when we click play, every enemy will have the copy of the material that is its own, so we are going to only tweak the material of a single enemy. But we do not currently have a way to do it. Now you can tweak the settings for this shader here in the material settings, or you can go to _material and choose the enemy default shader and enemy material, and now you will be able to tweak it here as well. But what we want to do is we want to make it run when we play the game. So to do that, again, we will need to implement a custom feedback. So let's go to our _scripts, to our feedback, right click, create, and we are going to create a new C# script. Let's call it dissolve feedback. Okay, let's open it up. Great. Now, let's delete the update and start methods. Again, let's extend the mono behavior, let's extend not mono behavior but feedback. Okay. And let's Alt-Enter on the dissolve feedback to implement this feedback. Great. Now, what we will want to do here is, again, we will need to have a reference to our sprite renderer. So let's create serialized field and let's create a private sprite renderer. And let's call it sprite renderer equals null. We are going to create serialized field and private float. We need to have the duration of this, so time, maybe something like this, or duration. And let's call it, let's set it to be 0.05, for example, 0.05f, and let's create another serialized field. And we will want to call, as you might recall, the enemy to be destroyed when we finish calling this shader or finish implementing this logic. So what we will want to do is we are going to create a prop, tab, and we are going to type Unity event, Alt-Enter, to be using Unity engine.events at the top here. And we are going to create a custom event. Let's change the name to be death callback. Okay, and now this will give us the possibility to assign to this death callback a function like a destroy game object, and we are going to be able to simply destroy our enemy when our dissolve shader feedback stops playing or finishes playing. So this is the way we are going to do it, to not wait in a coroutine in the enemy script, but rather to call this and destroy our enemy. On complete previous feedback, we will want to call our sprite renderer dot do complete, since we are going to use do tween, so do complete parentheses, and we can Alt-Enter on it and say using dg.tweening. So you could basically delete it and type dg.tweening and import this library on your own. Okay. So we have completed the feedback from for the sprite renderer, and we want to do it the same for the material. So sprite renderer dot material dot do complete. Okay. Now, if we want to create our feedback, again we are going to use our do tween asset that we have downloaded a while ago. Instead of throwing an error, we are going to call var sequence. and we can create a sequence of events that we want to happen. So we will need to make it equal to do tween dot sequence. And now this will work the same as we did previously with our do tween. So we can call sequence dot append, and we will append a behavior to the tween, and this will be added to the end of the sequence. So first we are going to create sprite render dot material, and we want to call do float. Since we want to tween the float value, we want to change the dissolved parameter from 1, which is not dissolved, to 0, which is dissolved. So we want to type 0 as the end value. This will be the end value. The property name will be parentheses underscore dissolve. You can go back to Unity and see if this is the correct name for your material. And next we are going to pass duration. Okay. And now what we can do is we can call if death callback dot actually is not equal to null, and we are going to call our sequence dot append callback, and this will allow us to append a callback to the end of a sequence. And what we can do is use a lambda expression, so parentheses equal greater sign, and we are going to call death callback dot invoke. Okay, and now when the shader finishes changing, or rather the do tween finishes changing the dissolve value of our shader from 1, which is the default value, to 0, we are going to call on the object to be destroyed. Great, let's save it. What we can do is go back to Unity. Great. We will want to go to our enemy chart, one of those, and we are going to right click here and create in the hierarchy feedback death. Okay, so just rename the game object name. And what we are going to do is add component, and we are going to call dissolve feedback. Now we need a sprite renderer, so again assign the avatar for the enemy. Okay, we can change that duration time to something longer, so maybe 0.7 should be good. Okay, and I can see that we didn't expose the Unity event, so click those 3 dots, edit the script, and above the death callback we want to add not serialized field, but field colon serialized field. Okay, save it. Let's go back to Unity. Great. And we want to add here the add component feedback player, of course. Assign the dissolve shader to the feedback player, and choose our enemy chart and add to on die. We are going to add another field. Let's assign our feedback death, and let's choose no function feedback player play feedback. And of course we will need to edit our enemy script, so click those 3 dots and edit the script. Great. Now beforehand in the get hit we have started the coroutine wait to die. We do not want that, so let's delete it, and let's delete our wait to die. Instead we will want to create public void die, maybe, and inside it this method we are going to call death destroy, and we are going to pass the game object. And that's basically it. So let's save it. Let's go back to Unity. Great. Now let's go back to our feedback death from our enemy, and let's assign a death callback here. Let's select our enemy chart, drag it as the object. From the functions list, let's choose enemy, and let's select die. We can choose our chart that we have edited. Now I have forgotten about one important aspect, that is that we are disabling the avatar, and we do not want that. So try clicking on this until you have this blue outline, and click minus to remove this event. Now again override apply, and now if we press play and we shoot our enemy, we should see the outline and the dissolve shader playing, and our enemy is being destroyed. So it is removed from the hierarchy, and it looks pretty spectacular. Now let's run towards our enemy, and you can see that animation works with this as well. So everything should work, and now it looks very nice. Now in the next video I would like to add a bit more to it. So now if we shoot our enemy, this red outline is pretty dim. I would like to make it more vivid. So we are going to add post-processing effect and make this color HDR. So hopefully our effect will look much better. So see you in the next video. In the previous video, we have finished implementing our enemy shader, so now if you press play and kill the enemy, it will be dissolved. Now, before we start implementing our post-processing, I would like to turn your attention to one issue that we currently have. If we click on one of those charts, preferably one that is visible already on the screen, I'm going to Ctrl D to duplicate it, and I'm going to place it near the other one. Something like this. I'm going to press play, and let's see if we can test it. If I'm going to shoot those two, both of those will get hit. Okay, here you can see that both of those were hit. And this is because our bullet is inflicting or causing the on-collision enter for both of those. And we are going to tackle it in the next video, how to fix it, as well as we are going to fix this issue with the bullets flying outside of our map. For now, we are going to take care of making our shader even better by implementing post-processing. So let's take a look at what post-processing is in Unity. Okay, you are in Unity documentation, and we can see that post-processing, Unity provides a number of post-processing effects and full-screen effects that can greatly improve the appearance of your application with little setup time. So basically what we can do is we can make the colors more vivid, make the glow more intensive, so to make our scene look more vibrant. And we have our rendering pipeline. URP includes its own post-processing solution, so that is our project, which Unity installs when you create a project. So we do not need to install anything else. And you can see that there are multiple of effects here. I'm going to leave this link in the description. What we are going to use is bloom effect. Bloom effects makes bright areas in your image glow. And that's what we are going to use. We are going to make our area of effect of our shader to be bright. And the bloom effect will make our red color glow instead of just being red. So let's go back to Unity. Okay. So how do we implement our post-processing effect? Well, we will need to go to our main camera. And here, what we will need to do is add component. So let's click it. And we should type volume. And you should have a script called volume. And basically, this is responsible for showing our post-processing effect. Now, what we will need to do is set the mode for global, as we want this effect to be present in the whole game. We could, of course, make it local and make it different for each area to make our ice area more icy, while the hellish area more hellish, depending on what you want to achieve. You can see that how the weight is, I think, how much it is impacting the game setup or the visual side of the game. Priority and profile. So priority, it means that you can apply multiple volumes per scene or per game, and you can set those priorities. Now, the profile is something that we will need to create, so we can use this new button, and it will create our profile. We can click it, and we will see that it is created in the scene, in the game scene, and we have our main camera profile. If we select this in our main camera profile in our project section, we can use the inspector, and we can add override here to this volume. Currently it doesn't have any overrides because post-processing effects might be intensive for the machine that you're playing the game on, so we want to only add those that we need. And since we only need the bloom effect, we are going to add override. Let's type bloom, and we should see the bloom effect. We want to only enable the effects that we want. We will want to have a threshold. Let's set it to something like 1, and intensity, let's set it to 0.3. Okay, now if nothing happens when you change those parameters, it means that this doesn't work. And why is that? Well, we will need to go to our camera, so choose in the hierarchy main camera, extend the camera script, and we have this rendering, and now we should be able to click this post-processing, and now our camera should have this post-processing applied. And if we slide it down, we should see our bloom effect visible. So let's add another override, and let's type vignette, just to test it if we can see this. Okay, I'm going to choose the intensity, I'm going to slide it, and you should see that we are changing this field of view of our player, so everything else is dark. So this means that our effects work, so I can click those three dots and remove this from our effect. We can of course choose the bloom, and it doesn't currently do much. Of course you can see the change in light from 0 to something more for the threshold, and intensity sure doesn't do much as well. So how can we use this effect if it doesn't do very much? Well, let's reset the threshold to be 1 and intensity to 0.3. And what we can do is we can modify our shader again. So let's go to our project section, choose the materials, and open up our enemy default shader. Double tap on it to open it up. I'm going to right click and maximize it so I can see it more clearly. And what we are going to do is actually not play around with the nodes, but what we are going to do is select the dissolve color from our blackboard, extend it, and we are going to choose the mode. And from the mode, from the drop down, we are going to use the HDR. And now what does it mean is that we are going to be able to choose the intensity of the color, so the brightness, and thus we are going to be able to make this color shine. So what we can do is simply save the shader, save asset. I'm going to minimize it. And what we are going to do is choose the enemy material and dissolve color. And here we are going to change the intensity to something like 0.2 or 0.4. What we can do is actually we can make our enemies dissolve. And you can see already that if we change the dissolve parameter, every enemy will start dissolving. As you can see, each is different because we are using the Perlin noise and the position of our enemy. Now still we don't see this post-processing to this full extent, so what we will need to do is go to our project section, slide down to find our settings, choose our universal rendering pipeline asset, and what we can do is we can in quality select the HDR. And now if we go back to our materials and select our enemy material, let's click on our HDR color and let's add one to it. And you can see that it has started glowing. Let's add +2, and you should already see that we have this awesome glow coming out from the enemies. Of course, it all depends on what you want to achieve. Let's set our value to something like 4. Okay, and let's reset our dissolve value to be 1 for all enemies. Now if we press play and we kill the enemy, you can see that there is a bit of a glow coming out of our enemies when they are killed. So this looks much better than what we had previously. Of course you can play around with the material settings for the color, so if you want to stop the game and make them more glowy, let's set this from 4 to 6 for example. Okay, let's close the color, let's play again, and you can see that this is much more glowy, this effect, and this depends on what you want basically. So I'm going to reset ours to something like maybe 4.5. It should be good value. And that's it for this video. So we have even more improved even more the effect. In the next video, we are going to perform quick fixes about the shooting bullets, and we are going to talk about hitting 2 enemies at once. So see you in the next video. In the previous video, we have improved our enemy animation by adding this glow effect on our shader by implementing the post-processing to our main camera, and thus we have achieved this effect that our HDR colors glow, making the enemy death animation pretty cool. Now what we want to do in this video is we want to perform quick fixes on our bullets. Now first of all, the easiest task is that our bullets fly out of the area of our game. So this is a very simple solution. What we will need to do is go to our scene view, make sure that we see all the area, go to our map that we have that contains our tile maps. To reopen the tile map tile palette, we need to go to the top menu window, choose the 2D section, and we should have the tile palette here. It should be open somewhere in your window. So I'm going to try dragging it a little bit lower, or sliding this using the handle on the edge of this window, and I'm going to dock it near the hierarchy. Now what we would like to do is we would like to choose the active tile map as the collision tile map, and we can choose from the hierarchy the collision tile map. so that we can see the gizmos. If you don't see them in the scene view, turn on gizmos. We are going to go to our tile palette, choose any wall tile, for example, and we are going to choose for example, this paint a filled box tool, so that we can paint this filled box from one side to the other. And let's add this outline around our walls using the wall, for example, so that we have a bigger collider around our walls. Now this should be it. So what we can do is right click on the tile palette and close this tab so we do not have any errors thrown by Unity because something is wrong with tile palette. Let's unclick the map. Actually, we do not need to see it. We can press play, and now if we go closer to our wall, our bullet will hit nothingness and will be destroyed. And it should work on each side of our gameplay area, so that we can now be safe that our bullets will not fly anywhere. Now the next one is what I have told you beforehand. If we press play, if we go to the two enemies together, both of our enemies are being hit by the same bullet. Oh, here you could have seen it. This is pretty simple. If we stop the game and go to our enemy, our enemy chart, we have our enemy script that, if you remember correctly, has an iHitable interface. It implements iHitable interface, and it is called get hit on it when the bullet collides with our enemy. So the collision is detected by the bullet. So this means that if we go to our underscore scripts folder and find out our weapons folder, I think, and we have our regular bullet, if we open it up, we will see what is going on. Great. Now our regular bullet has a rigid body and a collider. And since it has those, and this is a kinematic body, it has on trigger enter 2D, which is triggered when some collider collides or trigger collides with our bullet. And this happens on both of the colliders, so on both enemies at some points. So this means that if we want to have regular bullet that doesn't hit both enemies, we would like to implement some check. So if enemy on trigger enter 2D was already checked, and you might see that we are destroying this object, but so for some reason this code runs twice before the object is being destroyed, and I suppose it is because the destroy doesn't destroy the object immediately. What we can do is slide up and implement private bool is dead, and let's set it to be false. By default it is false, but let's set it to be false just to be safe. Let's save it. And what we can do is we can simply copy this name and slide it down to on trigger enter 2D. We are going to check if is dead. We are going to simply call return. And when is that is false, we are going to set is that is true. And this will protect us from two enemies being hit at once. So let's save it. Let's go back to Unity. And now if we shoot them, only one of them should be hit. So if you try it a couple of times, you would not see this effect of both enemies being hit by one bullet. So it all depends on what you want to implement. For me, for the assault rifle, I would like it to only hit one enemy, while, for example, implementing a bow or some sort of other weapon that could potentially hit two enemies, like sniper rifle, for example, I wouldn't bother with this is dead, and then it would hit both enemies, because what we have here is, I think inside the weapon data for the bullet data, we have this flag go through hittable, and we would use it to say if it goes through hittable, don't destroy it unless it hits an obstacle, for example, and then we will achieve this functionality for the sniper rifle or for the bow, that a bullet flies through everything that it hits, every enemy, until it hits an obstacle. Now we can go to the next video, where we want to add some time freeze, so when we are attacking our enemies, we would like the time to freeze a bit, so that we can add some anticipation, and hopefully the shooting mechanic will be more fun. So that's what we are going to tackle in the next video. See you there!